Hello, AP Stats. You're almost done with the first week of AP Stats. We have lesson 1.4. Kind of wrapping up a few things. You're almost there. This lesson shouldn't be too long. I really just want to clarify a couple things that I mentioned in the last video. And hopefully after today, you're in a better spot for the formative that is going to be done on Friday. Before I start, I want to tell you guys the way I've been doing these videos. I've been freehand writing, but every now and then I'm just gonna have to look at some document that I already have made like this, and I do not want you to freak out and be like, oh my gosh, do I have to write every single thing down? No, I'll tell you what's like the important stuff that you should have in your notebook, because I know many of you are following my directions and actually have like a stats notebook. So the objective for today, we want to interpret two-way tables by describing marginal distributions and conditional distributions. I would try to copy this chart down in your notes if you can, because that's going to be essentially what we're looking at, and that's going to help us with some of the questions. And then you're not going to put all these questions down in your notes. The only ones that I think you should put down are going to be B and C. These are going to be a little more important, I think. And also remember that you have access to this video forever. So if you ever want to just go back and rewatch the videos, you totally can. Alright, so let's take a second there and copy that chart down. You can pause the video here if you need to. I'm going to go ahead and read the prompt. So, to determine if people's preference in dogs had changed in the recent years, organizers of a local dog show asked people who attended the show to indicate which breed was their favorite. The information was compiled by dog breed and gender of the people who responded. The table summarizes the responses. So we can see that it's a two-way table, and our variable over here is sex. We have female or male. And then over here we have their favorite dog breed, right? Was it a Yorkshire Terrier or a Lab or other breeds? And we can see that not only is this a two-way table, but actually this is a marginal two-way table. And how do I know it's a marginal two-way table? Well, look, we have a row at the bottom with the totals, and we have a column on the side with the totals. So remember, now that makes this a marginal two-way table. Alright, so based on this, let's answer a few questions. These percent questions can be tricky, so a little more practice doesn't hurt. Number 1 says, what percent of the responses were from males who favor Labrador? So what percent of the responses? So of the responses is referring to all the responses, which we had 623. So what percent of these were from males who favor Labradors? Well, how many males favor Labradors? We have right here, males, labs, 41. And that's the fraction. In this problem, they specifically asked for the percent. So calculating 41 divided by 623, it's about 6.6%. I use my calculators, guys. I'm not that good. Number 2, what percent of the male responses favor Labradors? So of the male responses, that tells you that we're looking at the denominator being the male responses. So how many real male responses do we have total? We had 275. And of these 275, how many favored Labradors? Well, 41 did. And this fraction gives you a percent of about 15. And lastly, what percent of the people who choose Labradors were males. All right. So what percent of the people who choose Labradors? So on the bottom, or a fraction in the denominator, we're going to have the people who choose Labradors. Well, how many people chose Labradors? 78. And of those 78 people, how many were males? Let's see, 41. Calculating this gives you about 52.6%. So stats can be a little tricky with the wording, especially with these percent problems, but through practice you'll get better at these. So that's those. I think for the most part we're not having too many issues with this. I think this is a little easier of a concept. What I do think right now, many of you don't understand yet or don't have a solid understanding would be with these next two questions. What is the marginal distribution and conditional relative frequency distribution? So that's not on you guys. I just haven't explained it enough for you guys to understand what it means. That's why I'm making this video. So letter B, what is the marginal distribution of breeds? Remember, with margins, I want you to think of the outside. So you're either going to be looking at the column over here or the bottom row over here. Well, the problem says marginal distribution of breeds. So we're looking at the breeds, and we want to see the way that these breeds were distributed, and that tells you over here in the column, right? It says Yorkshire. Well, there was 132 out of 623. I really don't know how to pronounce that word. Dachshund. 96 out of 623. Golden Retriever, 91 out of 623. Labs, 78 out of 623, and so on. So all we would need to do for this one is go ahead and write down each of those things. I'm going to abbreviate. So YT, we can say that there was 132 of these out of a total 623. The D word, which I'm going to YouTube tonight and look how to pronounce that. 96 out of 623. Golden Retriever, 91 out of 623. Labrador, 78 out of 623. Dalmatian, I'm going to put DA for Dalmatian. And lastly, other breeds, I'll put an O. Alright, so you definitely need all these to describe the complete marginal distribution of breeds. These fractions tell you just how many of each breed there are. Alright, so like I said, if there's anything I actually do want you to write down besides the table, it's this question and this answer, and then letter C that we're about to do. So I hope that clarifies marginal distribution a little bit. Now C, what is the conditional relative frequency distribution? With this word conditional, I want you to think of, we're looking inside of the table. So marginal is on the outside, conditional is on the inside. Now, another word right here, relative. Remember I told you, if we see the word relative, we're actually going to have to make this a percent. That's not going to change too much. You'll see what I mean here in a second. So what is the conditional relative frequency distribution of the breeds among female respondents? So looking at my table, I can find the female respondents, and I'm looking at this column. Looking right here. And this is pretty much what I want to write down. I want to say that Yorkshires, they were 73 out of 348. But because the question did say relative frequency, remember relative, it means to find the percent. So we just have to take this one step further and figure out that this is, we'll say, about 21%. So about 21% of the female respondents preferred Yorkshire Terrier. Now we have to do this with actually all the breeds for females, because we want to describe the entire distribution of females. So Dachshund, 49 out of 348 total females. And that's about 14%. Golden Retrievers, we have 58 out of 348, which gives you about 17%. Labradors, 37 out of 348. %. Dalmatian, DA, 45 out of 348. %. And the last one, the other breeds, 86. Which is about 25%. All right, and that gives us the complete picture of the distribution for the female respondents. It lets us know how the females decided to vote on what their favorite breed was. 11% of the females liked labs, 25% of them chose other breeds. And think of how different this is from the marginal distribution, right? The marginal distribution, this includes both females and males, because we're looking at the totals. All right, so I hope that clarifies a little bit between marginal distribution and conditional distribution. Conditionals on the inside and marginals on the outside. And remember, we made these into percents at the end just because it said relative right in this little sentence here. All right, guys, I will see